not letting me record to the. Okay, token drop, and I have an interesting thing to talk about this week, which is context windows. I had a friend, I ran into a party, good friend of mine, and he mentioned something that I thought was very interesting. I had to write it down because I would have forgotten it otherwise. He said that algorithms are logarithmic, AI is quadratic. And he gave me this example of the sentence, I go to school. He says that in terms of tokens, the AI will first take I, and then it'll say, the LLM will go, I go to school. And when you do that, in that method of generating the tokens and parsing, it will really blow up your cost as the context window grows because of this quadratic growth in tokens. And he, sent me a follow-up message and explaining this in more detail. He said that, he gave me an example, like 1,000 tokens result in about a million attention operations versus 100,000 tokens result in 10 billion attention operations. And that's different than something like a database, which is more of a logarithmic compute. Here it is a quadratic compute. So it's basically his bottom line is that, with these AI models, a large context window can lead to an expensive cost because of this. I think I understood what the heck he was saying, but I wanted to pose it to you guys. So what do you think?
So he's partially right. I thought about this for some time, then I realized he's partially right in asserting that he's correct in asserting that the attention mechanism in an LLM, it compares every token with every other token in the sequence. It's an auto-regressive model. So in order to generate the next token, it does this computation where it compares every token with every other token. So that is an n squared. In computer science, there's a complexity notation called the big O notation. The big O notation tells you how complex a particular algorithm is. So the attention in the LLM, there is the attention mechanism is quadratic. It does quadratic computation. Effectively, it's n squared. When you have 100 tokens, you're doing 100 multiplied by 100 operations. So it's pretty expensive. And algorithms can well-designed algorithms can be efficient, but you can still just as well you can have a poorly designed algorithm that also has n squared complexity. So I'm assuming he's not referring to those people who do bad algorithm design.
Right.
He's referring to people who design algorithms thoughtfully and well. So, and those algorithms tend to be sublinear, right? They don't scale with the workload, that they need to process, with the number of tokens or number of elements they need to process. And in a database particularly, they go to extreme ends to make sure that those search algorithms, the sorting algorithms are sublinear. And when they're sublinear, there are, n log n or log n kind of algorithms. So the amount of compute needed to process a particular amount of workload is significantly lower if you plot them on that, XY chart. Yes, he's partially right, but where I disagree with him is even algorithms, if they're poorly designed, can be n squared, and we would urge people not to design algorithms that are n squared.
Right. He said that, newer architectures, and he gave me a list, linear attention, sparse attention, state space models, et cetera, attempt to reduce this towards O of n or O of log n, but standard transformer attention remains O of n squared, which is what we have today. So look like these newer things are trying to get better today.
They're trying to get better. They're trying to say, do we really need to compare every token with every other token? are those even relevant, right? Can we pick relevant tokens and then perform the n squared comparison from a smaller set rather than from a bigger set? So those are all optimizations, but foundationally, it's still an n squared algorithm, and there's no getting around it. So that brings us to an interesting topic, right? Which means then the longer the context length, the more you get to, the more you need to process, which is why, and the more you process, obviously it has an economic impact, it has an environmental impact, and therefore you got to seek other ways of, optimizing this compute. As he correctly pointed out, sparse attention, semantically selecting what the right token should be, state space models. There are a lot of different architectures that are, that come up in order to mitigate some of these risks. Sam, you want to say something?
Yeah, I mean, basically, right? I mean, you talked about it quite a bit. One of the things I wanted to really allude to is attention is quadratic, right? I mean, basically, cost per latency scale with sequence length. The structural reason long context is expensive, not just a pricing choice, right, at this point. But there are other constraints also there. KV cache is the real constraint. Then there's also this notion of positional generalization and things like effective versus advertised, right? But when we really talk about long context, who wins when we are talking about long context, right? Like tasks which need whole document structure, exact ordering or cross-section relationships. One coherent artifact, a contract, a code base must be reasoned over as a unit, right? But there is also this notion of retrieval, which is there, which wins when question and answers were a large corpus plus 3 to 5 relevant chunks, 4 to 8 K tokens, skip the middle of the context penalty, cut cost and latency, right? And secondly, retrieval is used when you need provenance, grounding, you can point to, right? So when we are looking at long context and retrieval are not really competitors. Rather, the winning partner is to use retrieval plus re-ranking, feeding a capable model, not stuffing 800K tokens of structured noise into every call, right? Same model, structured input, and lower cost, actually. That's where we are headed, actually. So yes, Sunil, in response to your question, attention is quadratic and stuff like that. But then again, there are ways to mitigate it, and that's what Sajaz has been also talking about, actually, right? Yeah.
Yeah, he said that increasing the context from 10K to 100K tokens, this is where he wrote in his note to me, increases attention work by about 100x. So you increase tokens by 10, and the attention work goes up 100. He said, really affects, doubling the context window quadruples the attention computation and memory, which I thought was really interesting. So if you have one of these big context windows on a newer LLM, which is more expensive than the older one, your costs can really go up tremendously.
Yes, and we're seeing that. These costs do go up, as you rightly said, quadratically, because the computation is quadratic. And those are expensive. It's quite expensive to process. But then I'll also take the flip side of that argument, which Sam was just alluding to. One is it's expensive, but then a million context length has become a million token context length has now become table stakes. Almost all of the frontier models are supporting a million tokens. And I'm sure the proprietary architectures from Anthropic and OpenAI, they must have invested significant R&D in optimizing the computational costs. But there's still no getting around the fact that no matter how much they optimize, they must be doing, as Sam said, sparse attention, semantically selecting only fewer tokens to process rather than all of the tokens. So, but those are all statistical operations, and eventually they all result in, if you're not, token drop. I mean, it's the name of a podcast. So if you're not processing all of those tokens, can it lead to some kind of a loss?
Yeah,
And the observation is when you have a million token window and you provide a million token document to the LLM to answer questions, what people have discovered is that in the middle of the document, there are facts. In the middle of the document, you might likely miss those facts. The LLM could miss those facts. What's at the beginning of the document and what's at the end of the document might get answered well, factually grounded, but what's in the middle of the document sometimes might not get answered.
interesting.
Yeah, so that's
Because they're dropping tokens? Is that this donut hole is because they're dropping tokens?
yeah, simplistically put, maybe that's what they do in order to do this million token n squared complexity computation. They got to be dropping tokens, right? I mean, you can't be processing n squared at that token at that context length. So they must be dropping some tokens.
Yeah,
They must have some algorithms to scientifically select what tokens to pay attention to, which tokens not to pay attention to. But what I think the end result is there's an enormous focus. There's a test called finding a needle in the haystack test. So they try to put the needle in the middle of the document and see whether the LLMs can get it. Now, I think most of the LLM providers have learned this trick and they're now trying to see if they can actually reliably find the needle in the middle of the haystack. Now, the next question is, can we hide multiple needles at various points in the document and then see whether the LLM can get it? Apple has not Apple, Adobe. Adobe has a benchmark called the No Lima benchmark. And not every LLM provider is advertising the results of that benchmark. There are good reasons why it's a pretty rigorous benchmark. And I mean, if a LLM were to pass that benchmark, I would say it's a pretty good LLM. So yes, it's a known problem, and people are trying to mitigate even against that problem by various means. And there are those who
yeah.
say, why do you need such a long token context length, right? Do you
Well,
really?
that's my question I was going to ask is could you make the argument that with a long context, you get an answer that you want more quickly? You don't have to ask the LLM 10 different questions. You just ask it one. So your total time, tokens to answer, so to speak, is much faster, much lesser if you do the long context. Because it gives you, with that context,
you
it
could.
gives you a better answer.
Ideally, yes. When the LLM is presented with the entire document and then you ask a question, it'll most likely be able to reason better and give you better answers as compared to chunking up the document and giving the LLM chunks of the document to fetch answers from the chunks of the document. Then the onus is on you to kind of stitch it all up. So that's where all these harnesses, graphs, and other things come into play. But the fact is, with this million context length LLMs, they are almost certainly dropping some here and there. We don't know how they're dropping, what tokens they're dropping, because of which we're also seeing hallucinations, and the hallucination is not going away. It's kind of orthogonal. The hallucination is there to stay. And does it increase with context length? Does it reduce with context length? Chances are that, no matter what you do to mitigate it, what they're saying is it's becoming an asymptotic curve. It's never going to go down to zero. It continues to remain there.
Yep.
So Sam, you have something to add to that?
Sam, look like you want to say something.
So basically, right, the core thesis is this, right? The 1 million token window is the megapixel race of LLMs, right? Every spec sheet has one. Almost no real workload uses it. What I'm saying is the advertised capacity is not the effective context. Production long context is an architectural problem which we have been looking at, not a model problem. So why is this the case, right? The context window is actually like what Sujata alluded to earlier. It's total tokens per request, system prompt, history, plus loaded docs, plus some model's own context, right? So what it boils down is approximately 0.75 words per token or something like that. When you exceed it, you can't send it. So as rightfully said earlier, you chunk, trunk, or retrieve that, right? I mean, actually. So if everyone has million tokens, why do teams still get burned? That's the question that you were raising, Sana, right? Well, there is this advertised versus the effective gap, right? I mean, a model's window is its capacity. Effective context is the length over which quality holds, right? And every long context benchmark ever published shows a gap here, actually. And why is that? There are three failure modes, which Sajad already talked about to walk through, like lost in the middle. And the second is the lost in the middle is documented 2023, reproduced on every generation since. Models retrieve reliably from the beginning and the end. Middle of the context, accuracy drops 20 to 40%. So a 200K window does not use all 200K equally, right? Second thing is the multi-needle, multi-hop collapse, right? Single needle find one fact. But multi-needle, like, MRCR V2.8 needles at 1 million, is where scores fall off at a cliff, which Sajad really did point to earlier in the conversation. The shape closest
You
to
said
real
it's
rag over
0.75.
long down.
You said it's 0.75 tokens per word, right?
Right. That is
approximately.
yeah. No, it's
So
0.75 words per token. Correct.
words per token.
It's
So
0.75 words per token.
so if I look at it, one word is 1 point something, two-ish type of tokens, right? So if I have a million token,
Million tokens is about what do you think is
750,000,
exactly about
words, right?
around
And
that.
so I did a quick back of the envelope calculation. That's 4,000 pages. To look at 250 words per page approximately,
Correct.
right? So
Correct.
let's say 4,000 pages, 4,000 pages.
Right.
What would I use? Where would I give it? You have to have a pretty hefty document to give it that type of context, right? What would I
Exactly.
give it? Where would I use 1,000, a million tokens? What kind of use case?
Yeah, actually, the place where you use it is where tasks need whole document structures, right?
Yeah.
And they need exact ordering, or they need cross-section relationships. That's where you use it, actually. You normally don't use it think of it like this: one coherent artifact, right? A contract, a code base must be reasoned over as a unit, as a whole unit, actually,
Mhm.
right? That's when you would do that. But I find it, most of the times in over a large corpus, you only, you use retrieval more than the long context, actually.
Yeah, it
That's
seems
my
like use
opinion.
cases where I want to compare documents or get answers across multiple documents. Those could generate a million tokens because you're going to stuff all those documents in the context window, right?
Yeah.
So if I'm trying to search one document, maybe not. It'd have to be a really heavy document. But if I have multiple documents, emails or things like that, I could see how I could get a million tokens.
Yeah, I think in legal use cases where you're looking at case law precedents for a given case, all kinds of evidence. Some of these court cases drag on for months and even years together. So in the period, I think they generate a lot of content to be able to understand that content and accurately surmise answers and deliver answers. I think in legal domain, I can see why you might need such a large context, provided it is reliable and dependable. So I guess, yeah, it's a function of the business users that we talk to and discover who might need such a large context length.
Yeah.
Yeah, 95% of the real workloads live under 128K, right? I mean, so, you need to pick the model by the retrieval shape of your job, not the headline number. If you go by that headline number, as I said, what you really are, in fact, the real reason is the advertised capacity is not the effective context, actually. That's where the disconnect lies, actually. And production long context is an architecture problem, not a model problem, as I stated.
Correct.
Okay. So I think you guys answered my question. I'm going to go back to my friend and tell him to listen to this podcast and let's see what he's got to say. Maybe we'll have him on someday if he's got something to
Yeah,
refute what we refuted.
even if it is not an LLM, one can design a sort where you're comparing every number with every other number and make it an n squared complex sort. And obviously, it's not efficient. When you're sorting at small scale, it might do the job, but when you're sorting with 1,000 numbers or when you're sorting with 100,000 numbers, if it's an n squared algorithm, then even that can be pretty inefficient. So, yeah, I think the complexity, whether it is an LLM or algorithms, if they have n squared order of complexity, then of course, you're going to get burnt. I think, and the database vendors, as you rightly said, would be using some of the most efficient searching algorithms, sorting algorithms. So even at very high volume and at high scale, they would be scaling their compute sublinearly. Yeah.
Yeah. Very interesting. Well, I think, is there anything else on this we want to discuss? Otherwise, I think we can close up our podcast today.
So one thing is, to really close this up, let me answer these four questions, right? Which you were asking. Like, does a bigger window just make a RAG obsolete? No, it doesn't. Middle of context penalty and cost bar latency scale against you. So therefore, RAG narrows what the model must attend. So they compose, right? That's first thing. Second thing is, it's always a choice of the model. For say a 200-page contract, 6 interrelated questions, what do you use? You use a 32K to 128K multi-needle zone, right? So is 10 millions real? Advertised, yes, but no. Public evidence of anyone running quality workloads near it is not there, right? And how do we measure our own effective context? We need to build that domain needle test, which Sajjad said, and it needs to be a multi-needle, and we need to figure out that all the needles can be related together, right? That's where we stand. Even though, so bottom line at the end of the day is, even though you have advertised context, now the effective context is not the same, actually.
Cool. Thank you, Sam. Thanks a lot.
Okay. Can you guys hear me? I think I'm having some trouble with my network.
What happened?
No, I think we
All
can hear
right.
you. Yeah.
Okay, I think then I better stop while I'm ahead because I keep getting these network is unstable messages on my side.
Yeah. I don't know whether it's mine. I'm traveling.
I
Thank
don't
you.
know. I think
Yeah.
it's mine. All
Yeah.
right.
See
I'll
you guys.
talk to you
Bye.
guys later. Thank you.